Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today we will be exploring more about equilibrium of forces with the topic parallel forces, a continuation of our previous lesson. But before we proceed, let's quickly recap what we learned in our previous lesson. In our last lesson, we defined moments of force, exploring its formula and examples. We also understood the principle of moments and applications of torque. And it was very interesting. Before we begin today's lesson, let's take a quick look at our lesson objectives. By the end of today's lesson, you will be able to define parallel forces, identify the types, and solve calculations on parallel forces, and explore Archimedes' principle. Are you ready? Let's proceed. Just as we have defined what forces are in our previous lesson, parallel forces are two or more forces that act in the same or opposite directions and remain parallel to each other. These forces do not intersect or converge. This means that the lines of action of parallel forces remain equally spaced and will never cross each other. They never meet, no matter how far they are extended. Types of parallel forces. There are two main types of parallel forces. 1. Like parallel forces, these are forces that act in the same direction. Example, pushing a car together from the same side. 2. Unlike parallel forces, these are forces that act in opposite directions. Example, tug of war, where forces act on the same object in opposite directions. Or a seesaw with weights on both sides. Conditions for equilibrium. For parallel forces to be in equilibrium, the sum of forces in one direction should equal the sum of forces in the opposite direction. And the resultant moment about any point is zero. Let's learn about resultant force in parallel forces. The resultant force is the single force that can replace multiple parallel forces without changing the effect. It determines the motion of the object, whether it accelerates, remains stationary, or moves at a constant speed. Formula for like parallel forces. When all the forces act in the same direction, the resultant force is the sum of the individual forces. Note that sum means addition. Therefore, F resultant equals F1 plus F2. Formula for unlike parallel forces. When the forces act in opposite directions, the resultant force is the difference between the larger force and the smaller force. Note that difference means subtraction. Therefore, to solve for unlike forces, F resultant equals F1 minus F2. It can also be stated simply F larger minus F smaller. Note that direction depends on the larger force. In the formula for resultant force in parallel forces, F1 and F2 represent the individual forces acting on an object. Each F corresponds to a force, with magnitude and direction. Let's go ahead to solve some example problems using the formula. To solve for like forces. Two parallel forces, F1 equals 20 N and F2 equals 30 N, act in the same direction on a beam. Find the resultant force. Solution. F resultant equals F1 plus F2, which equals 20 N plus 30 N, which gives us 50 N. The resultant force is 50 N in the same direction. You are doing great. Now let's solve for unlike forces. Two parallel forces act on a plank, F1 equals 50 N to the right, and F2 equals 30 N to the left. Find the resultant force and its direction. Solution. F resultant equals F1 minus F2, which equals 50 N minus 30 N. That gives us 20 N to the right. Good job. Next, let's learn about the Archimedes principle. Archimedes principle defines the behavior of objects in fluids, liquids or gases. Archimedes principle states that, when an object is wholly or partially immersed in a fluid, it experiences a loss in weight or an upthrust, which is equal to the weight of the fluid displaced by the object. This principle explains why objects float, sink, or remain suspended in a fluid. Let's demonstrate this with a practical example. Make sure to get these items to experiment and observe the outcome. In a big container filled with water, take an empty bottle, a partially filled bottle, and a fully filled bottle. Submerge them in water and observe. It is expected that the empty bottle floats, the partially filled bottle floats lower, and the fully filled bottle sinks. This experiment simply explains the Archimedes principle. The images show the object that sinks, floats and lowers gently. Let's see the applications of Archimedes principle. 1. Ships and boats. They float because the upthrust force balances their weight. Even though they are made of heavy materials, their design, hollow and large volume, ensures enough water is displaced to balance their weight. 2. Hydrometers. These are devices used to measure the density of liquids. A hydrometer floats at different levels in a liquid, depending on the liquid's density, based on Archimedes' principle. And so much more. You can go further to explore these applications. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Well done. You've done an excellent job keeping up with today's lesson. Let's recap. Parallel forces are forces that act along parallel lines, either in the same direction or in opposite directions. These forces do not intersect or converge, which means they never meet, no matter how far they are extended. Archimedes' principle explains why objects float, sink, or remain suspended in a fluid. In our next lesson we will be learning about equations of uniformly accelerated motion. Well done. You've come to the end of this lesson. Keep practicing what you've learnt. I will see you in the next lesson.